Welcome to the physics class and the teacher Black Adam. Small ball rolls horizontally off the edge of a tabletop, height 1.2 meter, and the floor is 1.5 meter horizontally, the length. So let's imagine this is the table that we have. So sketching up the problem helps us to solve it. So that's the ball. The ball actually rolls from there. That's the trajectory up to the edge, and that's our table. And then from there, that's the ground that we have. This is our ground, and then that goes straight down, and this is our height that we have, and our height is 1.20 meter, and the ball falls on the ground. So that's the top and the bottom, and it actually rolls from that part there, from the start. Just imagine, and it keeps moving until it reaches the end, and then the horizontal distance that it traveled, that is 152 meter, and we have A there. That how long is the ball in the air, and we know that the ball in the air, we use the equation changing y is equals to 0 minus going down is negative, so it's going to be minus bracket minus 1.20 meter. The reason why it's negative 1.2 is because going down is negative. So if going down is positive, you can also change that. And then we have 1.20 meter. And the other thing that we do is we use the equation of motion. So it's initial position, wherever it's 0 or whatever it is. And then we have initial velocity, vertical, multiplied by sine theta, sine of the initial angle that it took. Because we know we have an angle that it goes up with, and then the angle with which it drops. So that's the angle with which it takes off. Then minus a half, we have g change in t squared, and with that we have theta is equals to 0 degrees, and then we have that part there which gets to be 0 because sine 0 is 0. So we have change in y without the first part of the equation, so it's negative half g change in t. That's like change in t squared. That's 1.20 meter, negative half, negative 9.8 meter squared, and all that. That's t squared, and that's change in t squared. So that's change in t squared, and change in t, when we simplify everything, it's going to be plus or minus root of 2 times 1.20 over 9.8, and that gives us 0.495 seconds. So that's our answer for number 1. Going to number 2, what is the speed? What is its speed at the instant it leaves the table? So we have change in x there as 1.52 meter, so it's 1.52 meter, and then from there we have change in x there is equals to the equation initial position, whether 0 or whatever given, and then initial velocity multiplied by cos theta, and then all of that multiplied by time minus a half of gravitational acceleration multiplied by time squared. And then that part will be 0 because it's not moving vertical, so that part doesn't exist. So theta is initial theta, initial angle, that's going to be 0 degrees. And then when you say 0 degrees, we have cos 0 degrees giving us 1. So when you put cos 0 degrees there, gives us 1. So 1 times initial times t, and that part there is not applicable, so it doesn't, because it's vertical motion part. doesn't have horizontal, doesn't include acceleration, so that's going to be initial velocity multiplied by change in time, and that gives us initial velocity as 1.52 meter is equals to initial that's displacement, that's 1.52 meter. Initial velocity we don't know, and then time is 0.495 seconds. And what we do, we solve for v initial, so initial velocity is going to be 1.52 meter over 0.495, and all of that gives us 1.52 divided by 0.495 gives us 3.07. So it's 3.07. That becomes our answer, 3.07 meter per second. Thank you so much for watching, and this is your tutor Black Adam. And don't forget, if you have any problem, to put in through the website, through the channel, so that we can go through them. And if you do have any question, please don't hesitate to follow or subscribe or email me on the email provided. This is your tutor Black Adam. That's it. So one way of supporting, if this has really been helpful to you, please don't forget to subscribe or follow, as this will just improve in terms of support of the channel. Much appreciated. And any question, leave below. Thank you.